3, we'll try something that's not very confusing. Well, actually, it is going to be confusing either way. All right, so let's do it this way. 0, -3, and no. We start with line 1. Now remember, we always start with line 1. Okay, because some people, when we look at it, okay, if you just present the algorithm to someone, who has not taken any classes in programming, and you say, okay, if I tell you that x starts with a value of 0, y starts with a value of -3, what would z become? You know what? Some people will scan through the conditional statement and immediately spot on line 3 and say, oh, when x equals to 0, we're going to do this to z. But that's not how the computer is going to execute this statement. The computer doesn't scan, visually. The computer always executes top to bottom, line by line. Okay? So that is a very important thing, is we have to follow the same rules in this class. Always start with line 1. Okay, line 1 is asking that question. X is less than y is false. Very good. Then where do we go? Then we go to line 3, right? So now we go to line 3. Line 3 is going to ask the question, is it true or is it false that x equals to 0? That is true. Then where do we go? We go to the branch of this particular condition, which is line 4. Line 4 is going to change z to 2, and we're done, right? But hold on a second here, Tack. I can see on line 7, that condition, x is greater than or equal to y, is also true. What about that line? We never get to that point, okay? Because if there's one branch and its condition is true, you execute that branch, and then you get out of the entire conditional statement. It doesn't matter how many other conditions are also true after that. It just doesn't matter. Is that okay so far? All right. So let's go ahead and start with another test case. But this time, I'm going to change the problem a little bit in nature. Instead of giving you the values to begin with and ask you, what the program is going to do, I'm going to change the question. Instead of asking that question, I will say, how can I, initialize x, y, and z? Well, z doesn't really matter, but how do I initialize x and y so I can end up on line 10 so that z can end up with a value of 5? How do I make that happen? So z is unknown to begin with. I want it to be eventually 5. How do I make it happen? How do I, initialize x and y to make that happen?
Let's be equal.
You cannot. It's not possible.
Because the x is greater than or equal to y condition.
It is not possible because this one catches all the cases when x is less than y. And we have some in between stuff here to look for very specific stuff. But then we have this one here to catch all the other cases, right? Given two values, x and y, and both are numbers, it's either true that x is less than y, or it is true that x is greater than or equal to y. Okay? So one of these two conditions, on line 1 or line 7, one of them has to be true. Well, we cannot get to line 10 unless all the conditions of line 1, 3, 5, and 7, if they're all false, then we can end up on line 10. But this is a guarantee that that will never happen. So that means, in this case, if I ask you a question like that, you just say it is not possible. It is not possible to find values for x and y so that we can end up on line 10. Yep.
Theoretically, could you start x as unknown and then it would hit line 10? Because if you started as unknown, it doesn't mean any prereq. Well, it doesn't at the same time.
Well,
kind of Schrodinger's cast out.
You cannot trace a program. This is what we're doing. Up to this point, we are tracing the program, which means we're executing the program as if we are the computers, right? Mm-hmm. But if you don't know the value of x, there's no way to perform a comparison.
Okay.
Or it just post.
Hmm?
The program will just post.
No, the program will do something. I just don't know what it's going to do, right? because the value is unknown. So there's no way to trace it because I just don't know what the program is going to do. Yep.
Is the value unknown just to the user, or is the value unknown to the computer?
The value is unknown to the user, so when you run the program, it will do something depending on the actual value in X and Y. But then I cannot trace it anymore as a person because I don't know what it is. The machine knows what it is. But when you're writing the program, if you don't know the exact value of X and Y, then there's no way for you to predict what the program is going to do. Is that okay? So there's a limitation to this approach of what we call tracing a program. All right. Now I also kind of promised you guys the other thing to kind of clarify what is equivalence, what is implies and implied by and that sort of thing. So we'll spend some time to talk about it. I think 10 minutes may just be enough to do it. So go to accessories, go to bounce pad, and just go ahead and write this out as a document. All right. Instead of using all those terms, which can be kind of confusing and boring, I'm going to say something like this. I would say, if it is cloudy, tech wins the lottery. Okay.
Freaking awesome.
Seattle do it now.
All right. So, okay. Let's make it this way. Let's say that you win the lottery. All right. So somebody. So okay. Let's just say that I'm now known as Tech the Oracle. Okay. People come to me and ask me questions, and I'll answer those questions, right? And I'll spew out statements like this. So people pay me $100 and I'll give them a statement, okay? And so the question is, when can you get your refund? because what I said is false, okay?
Total sense, no refunds, problem solved.
So that's what we are doing here, okay? So it doesn't have anything to do with programming now. Okay, so what are the 4 scenarios that can happen in this case? All right. It can actually be cloudy outside and you win the lottery. It can be cloudy outside and you did not win the lottery. It is not cloudy outside, you win the lottery. It is not cloudy outside and you do not win the lottery. Do you get a refund in each case? Tell me whether you should or should not get a refund. Okay, so in the first one, it is cloudy outside, and you end up winning the lottery. Of course, in that case, you don't really care whether you get a refund of $100 or not.
Yeah.
But should you get a refund?
No.
Nah. Okay. Well, I should probably change this to was tech right. Okay. How about that? Okay. So in the first line, I was right. Okay. What I said, was consistent with, the outcome. So the other day, it's cloudy. You did not win the lottery.
Yeah.
Can you say what I said it was false?
No.
Yeah.
Well, you
Yeah.
didn't give it a time constraint.
What?
You didn't give a time constraint.
I did not give it any time constraint. I'm simply saying, there's no causal relationship either. I did not suggest that being cloudy is what is causing you to win the lottery. I'm simply saying, if it is cloudy, then you win the lottery. Okay. So in this case, the answer is false, right? Because it's cloudy and yet you did not win the lottery. What about the last 2 cases?
False.
It is not cloudy outside, you win the lottery. Can you say what I said was false?
Yes.
Yeah. So I was right?
No, you're wrong.
No, I was right. Because I did not say anything about what if it is not cloudy. Yeah. Well, this is the meaning of the word if combined with then from the perspective of logic. Okay. So from the perspective of logic, there's another way to look at this. Okay. You can say that this is saying, it is cloudy is a sufficient condition of you win the lottery. Okay? The statement here is really saying the same thing as here. Okay? If it is cloudy, you should win the lottery. Now, but it doesn't say anything about what if it is not cloudy. So as a result, if it is not cloudy and you win the lottery, it's still consistent with what I said. If it is not cloudy and you did not win the lottery, it is still consistent with what I said. Now let's go ahead and play with words a little bit. This time we use only if. Okay, so I'm changing the sentences just a tiny bit of, instead of using if, I use only if. So these things have to be changed a little bit. I want you to tell me which one I can change.
Sure.
So I say only if it is cloudy, then you can win the lottery. It is cloudy, you win the lottery. Was I right? Okay, what I said was true. Now here's the tricky one. It was false before. Only if it is cloudy, then you win the lottery. Okay, it's a cloudy day and you did not win the lottery. Can you say what I said was wrong? No. Because I said only if it is cloudy, then you win the lottery. I did not say all the other conditions that also have to be true for you to win the lottery. I'm only saying that this may be one of the many conditions that have to be met so that you can win the lottery. Okay? So I'm actually okay. I don't have to give you the $100 refund so you can buy 100 more lottery tickets. All right, what about this one? It is not cloudy and you win the lottery. Can you get your refund in that case? Yes. Answer is yes, very good. So this time I was actually wrong. Because if I say only if it is cloudy, then you win the lottery, it means you win the lottery. There may be many other conditions, but being cloudy is one of the required conditions. So if you win the lottery without being cloudy outside, then what I said is wrong. Of course, in that case, you don't really care about the $100 that you are going to get back from me. Okay, how about the last one? It is not cloudy.
True.
You did not win the lottery. Was I right?
Yes.
I was right. Okay. So the other way to phrase this, if I were to use the words sufficient and stuff like that, this time it is not a sufficient condition anymore. It becomes a necessary condition. Is that okay so far? What if I change my statement one more time? And this time I use, I will start with this. I think it's IFF, if and only if. Okay, I'll spell it out. If and only if it is cloudy, then you win the lottery.
It's both.
So let's see when the statement was true and when the statement is false. Okay, it's cloudy, you win the lottery. Is the statement true or false? Statement is true. What if it is cloudy and you did not win the lottery? Statement is false. What if